Okay, so we're going to talk about how we graph inequalities. So this is when our y equals mx plus b graphs come slamming into this inequality situation. So it's going to look something like this. We're going to have y is greater than 2x minus 3. So this looks a whole lot like what we're used to. You've got your mx plus b format here, but instead of an equal sign, we've got this inequality sign. Now, here's what we know. We know that this is an inequality sign, and when we have a greater than or less than sign, that's going to create a dashed line on our graph. And if we have greater than or equal to or less than or equal to, that's going to create a solid line. So we're going to start off by graphing this as per usual. So we've got an x-intercept down here, y-intercept down here at -3, and our slope is 2 over 1. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, and that creates my positive slope. Now, this is greater than. There's no equal to, which means I'm going to use a dashed line. So I'm going to come over to my graph and I'm going to connect all of these coordinates I just put down with a dashed line. So I'm going to use a dashed line. Now that I've got that figured out, I need to decide which range of graph coordinates is going to be my answer, right? Because inequalities mean there's a range of numbers. So instead of just having this line, I have to pick a side of the graph. To do that, I'm going to choose a test point. And as long as your line doesn't cross through 0, 0, the origin 0, 0 is about the easiest point to pick. And the reason is because they're just really easy numbers. So remember, coordinates represent an x and a y value. And if you look really closely, oh, here's an x, here's an x, here's a y, here's a y. So we can plug this x into this x and this y into this y. So we're going to do that. We're going to test this point. And to do that, I'm going to end up with y, which I said is 0, is greater than 2 times x. Well, we're using 0 for x. Minus 3. So now look at this and just kind of just chug the numbers here, like crunch them. We've got a 0 is greater than 2 times 0, which is 0 minus 3, so -3. And now ask yourself, is 0 greater than -3? And the answer is yes. So this is a true statement. So this is true. And because a coordinate on this side of the graph made it true, means that every other coordinate over here will also give me a true statement if I plug them in, literally any of these. So to show that this entire side is true, I am going to shade this entire side of the graph. Literally the whole thing. I'm going to shade the whole thing. And what I'm representing with my shading is that this entire side of the graph gives me a true statement and satisfies this, this inequality. If I plug in points on the other non-shaded side, it won't work. It'll give me something backwards. It would give me something like 5 is greater than 10, which is not true. So only this side gives me true statements. Okay, let's look at another one. Hold on. Okay, let's try this one. Let's say y is greater than or equal to -1/2 x plus 4. So same process again. This thing is in slope-intercept form. If it's not in slope-intercept form, you need to rearrange it and put it in slope-intercept form. You can watch the other lesson video on how to do that. But this one already is. We saved ourselves that step. So our y-intercept's up here at 4. I've got a negative slope of 1/2. So I'm going to go down 1 over 2, so I get a negative slope. So down 1 over 2. And now I'm going to connect my lines. Remember that we said if it's greater than or equal to, you have a solid line. And if it's just greater than or less than, it's a dashed line. So this time we're going to use a solid line. And it's going to kind of look like it always looks, because the coordinates on that line can be part of our answer. So now that we've done that, we're going to pick our test point. And our test point, 0, 0, is going to work here because it's open, like it's available. The line isn't going through it. So I'm going to choose this as my x and y to test. Remember, this is an x, this is a y, so I'm going to plug those in. So 0 is greater than or equal to negative 1/2 times x, and I'm testing 0 for x, plus 4. All right, so 0 is greater than or equal to negative 1/2 times 0 is 0. 0 plus 4 is 4. Is 0 greater than or equal to 4? And the answer is no. This is a false statement. False statement. So because it's false, because this one spot is false, means this spot and 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 this, all of these are all going to not work. Therefore, the answers have to lie on the other side of our graph. So we are going to shade the opposite side of our line, which is just this tiny corner up here. All right, so when we got a false answer, we shade the opposite side. Okay, the technical name for this area that you've shaded is, it's all the answers, and we call it the solution set. So if you're asked to find something in the solution set, it's going to be in the shaded area. And you can say like, oh, this point is part of my solution set. That's 1, 2, 3, 1, 2, 3, 4. So point 3, 4 is part of my solution set. So is point 4, 3. There's lots of points in there that'll work, and they're all part of your solution set. Now, once we can do this with 1, we can start doing this with 2 or 3. So for example, we might have something like this. Y is greater than, let's say, 2/3 x minus 1. And then we might also have x is greater than or equal to negative 4. So in this case, we're going to have to graph both of these lines on one graph. So watch what happens when we do that. So we're going to do the same thing we've been doing. I'm going to start with this one, and I'm going to do it in red. So I'm going to come down here to my y-intercept, and I'm going to go up 2, and I'm going to go over 3 so that I'm getting a positive slope. I can also go down 2 and over 3 this direction. And then this is a greater than, so I'm just going to put a dashed line. Dash, 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 dash. And I'm going to choose my test point. I'm going to choose 0, 0 again. So I'm going to say 0 is greater than 2/3 times 0 minus 1. Is that true? Is 0 greater than negative 1? Yes, that's true. So I'm going to shade this whole red side of my graph. Ooh, okay, all the way. And you have to go to all corners of the graph. You'll see why in a second. Okay, so there's 1 down. Now I'm going to do my next inequality in blue. And this one's a little bit shorter. This just says x is greater than or equal to negative 4. Now remember, when we have lines that look like this, they're going to be, this has no slope, right? It's only giving me an x. So I'm going to come over here to negative 4 on my x-axis. And this is going to make a vertical line. And because it's greater than or equal to, this is going to be a solid line. So I'm going to draw this solid, right? So you can see it. And then I'm going to ask myself the same test point situation, except this time I'm going to pick 0, just like I did before. And I'm going to ask myself, is 0 greater than or equal to negative 4? And the answer is yes, 0 is bigger than negative 4. So therefore I'm going to shade, but in my other color, this entire side of the graph. Okay? So now I've shaded this whole side of the graph. And so here's my question now. Now, where's my solution set? What area of the graph is covered by red and blue? This thing, right? So now our solution set is what we call the overlap. So this is the overlap, and it's the solution set. So that means that any coordinate that's in both the red and blue part will make both of these true. If it's only in the blue, it's not going to work for the red. So it doesn't make both of them true. So all we've really done is we've put 2 on our graph, and we're looking for the place where they overlap. All right, be careful when you've got functions that are just an x or just a y. They're going to be horizontal and vertical lines. Make sure you draw all the way across. Make sure you shade the whole thing. Remember that greater than or less than is a dashed line, and greater than or equal to and less than or equal to is a solid line. All right, that's it.